Today we're going to work on solving square roots and other radical equations. A radical equation is an equation that has a variable in the radicand or a variable with a rational exponent. If the radical has index of 2, the equation is a square root equation. When solving any radical equation, you first want to isolate the radical, then eliminate the radical, and finally simplify. Example 1. Find the solution. In example 1, we have the square root of 4x plus 1 minus 5 equals 0. Again, the first thing you want to do is isolate the radical. In order to do so, we need to add 5 to both sides of our equation. That will leave us with the square root of 4x plus 1 equals 5. Now that we've isolated the square root, we can eliminate the square root. The opposite of a square root is squaring, so we're going to square both sides. And that will give us 4x plus 1 equals 25. Now subtract 1, we'll get 4x equals 24. Divide by 4, and x is equal to 6. Now, whenever you square a radical equation, there's always the possibility that you're going to introduce an extraneous solution. So in order to avoid this, well, we can't really avoid it, but we need to check and make sure that we do not have any extraneous solutions. So we're going to take our original equation, and instead of writing x, we're going to put our solution, in this case, 6. So 4 times 6 is 24, plus 1 is going to give us 25. Square root of 25 is 5. Minus 5, and that is 0. And that indeed is what we wanted, so x equals 6 is a true solution. It is not extraneous. But what if the equation we have is not a square root? Well, to solve equations of the form x to the m over n equals k, we raise each side of the equation to the power n over m, which is the reciprocal of the current power m over n. Let's do an example so that this makes some more sense. For example 2, we are again going to find the solution. Here we have 3 times the fifth root of x plus 1 cubed plus 1 equals 25. First, I'm going to rewrite the radical using a rational exponent. So we have 3 times x plus 1 to the 3/5 power plus 1 equals 25. Now we're going to subtract 1 from both sides, and that will give us 3 times x plus 1 to the 3/5 power equals 24. Now we need to divide both sides by 3, again isolating our rational power. So x plus 1 to the 3/5 power is going to give us 8. Now, this is where what we just talked about comes into play. We essentially want our exponent to equal 1. In order to get 3/5 to equal 1, we would have to multiply by 5 over 3. So using our properties of exponents, we need to raise this to the 5/3 power. We're going to do that on both sides. On the left-hand side here, the powers are going to cancel out because 3/5 times 5/3 is 1. So again, they essentially cancel, giving me just x plus 1. And then we're going to rewrite the other side as a radical. We're going to have the cubed root of 8 to the 5th power. It's a little easier to solve that way. When we take 8 to the 5th power and then take the cubed root, we will get x plus 1 equals 32. Subtract 1 from both sides, and x is equal to 31. Now, like I mentioned earlier, when you raise each side of an equation to a power, it is possible to introduce extraneous solutions. It becomes important to check all solutions in the original equation. Correct solutions will give true statements, while extraneous solutions will give false statements. In example 3, we're going to find the solution and check for extraneous solutions. We have the square root of 5x minus 1 plus 3 equals x. I know this one's different because there are variables on both sides now, but the process is still the same. We need to isolate our radical first. So we're going to subtract 3 on both sides, to get the square root of 5x minus 1 equals x minus 3. And then we're going to eliminate the radical, so square both sides. And we'll get 5x minus 1 equals x squared minus 6x plus 9. Now, this is like when we did systems earlier and we had the intersection of a linear and a quadratic system. We need to get everything to one side and set it equal to 0. So we'll get 0 equals x squared minus 11x, and then plus 1, so plus 10. And now we can factor and simplify. So we need two numbers that are going to multiply to give me 10 and add to give me 11. So we've got, that'll be 10 and 1, so x, negative 10, negative 1. Solving both of these for x, we'll get x equals positive 10 and x equals 1. But like we said, it's possible that we just introduced an extraneous solution, so we have to check our answers. Plug back into the original equation. If we plug positive 10 back in, we'll get the square root of 5 times 10 minus 1 plus 3, and hopefully that will equal 10. So 5 times 10 is 50. 50 minus 1 is 49. The square root of 49 is going to give us 7. 7 plus 3 is indeed 10. So 10 is a true solution. But we need to check 1 as well. So the square root of 5 times 1 minus 1 plus 3, again, should equal 1 this time. So 5 times 1 is going to give us 5. 5 minus 1 is 4. The square root of 4 is 2. And 2 plus 3 is going to give us 5. 5 does not equal 1, so 1 is not a true solution. X equals 1 would be extraneous. Now, it's also possible that an equation can contain two radical expressions. If this happens, isolate one of the radicals and then eliminate it. Here's a hint. Always isolate and eliminate the more complicated radical first, then simplify before eliminating the second. For example 4, we need to find the solution and then check for extraneous solutions. We are given the square root of 2x plus 1 minus the square root of x equals 1. So what we need to do, again, get rid of the more complicated radical first. So we're going to get the square root of 2x plus 1 by itself because it's more complicated than just the square root of x. So to do that, we're going to add the square root of x to both sides, leaving us with the square root of 2x plus 1 equals the square root of x plus 1. Now, since we've isolated the more complicated radical, we need to eliminate it, so we're going to square both sides. That will give us 2x plus 1 equals x plus 2 square roots of x plus 1. So now that we've gotten the more complicated radical gone, we can focus on the other radical. So let's isolate that one now. We need to subtract x from both sides, and we need to subtract 1, and that will give us x equals 2 square roots of x. Now, you can divide by 2 on both sides first if you want, or you can go ahead and just square both sides. Either way is fine. Squaring both sides, we'll get x squared equals 4x. Now again, we're trying to solve for x, so let's move the 4x to the other side, set this equal to 0. We'll get x squared minus 4x equals 0. You'll notice that they have an x in common, so let's factor that out, greatest common factor. Setting both parts of this equal to 0, we'll get that x equals 0 and x equals 4. However, we're not done. Because we squared something, we introduced the possibility of an extraneous solution. So what we need to do is we need to take the solutions we found and plug them back in. So starting with 0, we'll have the square root of 2 times 0 plus 1 minus the square root of 0 equals 1. Again, using the principal root when simplifying this. 2 times 0 is going to give us 0, plus 1 is 1. The square root of 0 is 0. 1. The square root of 1 is 1 minus 0. Hopefully it will give us 1. And 1 minus 0 is 1. So x equals 0 is one of my solutions. We need to do the same thing with 4. So we get the square root of 2 times 4 this time, plus 1 minus the square root of 4. Again, hopefully will give us 1. 2 times 4 is 8. 8 plus 1 is 9. Square root of 4. Square root of 9 is 3. Square root of 4 is 2. And 3 minus 2 is 1. So again, 4 is also a solution. Here are 6 questions to reinforce what we talked about. You need to solve each of these and check for extraneous solutions. These are the questions I will be checking for at the beginning of class tomorrow. So good luck and make sure you check for extraneous solutions.